Good afternoon, everyone. Hope all is well. This is workshop 2 of our Aptos Educate series. I am Anthony, the CEO of Encode, so you're in great company today, and I'm going to talk you through a bit of stuff about Move and everything that comes with it. Let me get my slides going. One second. How are we going to do this? Ba-ba-da-ba-dee-boo. Cool, let me share. Want to share. Right, let me try that. Hopefully. Nope, that looks shit. That's pretty good. Cool. Now let me get presenter view. Should come with a second screen. Nice. Okie dokie. Hopefully everyone can see that. Right. Okay, everyone. So you will have interacted with this program through the Encode Club new platform. It's a new platform we built for 2025 to be a better experience for all your hackathons, education series, accelerators. The past workshop is available on that platform. In fact, you know what? Why don't we have a look at the platform itself? Hopefully everyone can see that. Yes, you can. So on encode.club, encodeclub.com, you can see all the programs that you are participating in. I can see everything because technically I'm the boss. I participate in all of them. You should have this available to you to talk about what workshops are coming up and are happening. If you go to the program itself, you can see this workshop now. So you clearly did this bit correctly. And also the past workshops, the one I delivered on Tuesday, which you can watch and go through everything we talked about, and other programs also happening run by Encode at the moment. You also can see things like our alumni, ecosystem of partners we work with, and our London hub, which we're very proud of, which I am sitting in at the moment. If you're based in London, you want to co-work, join events, and join a broad Web3 AI community, you come here. Very nice. Okay, so let me switch back. 1 second, I'm very slow. I want... Come on, Canva. Nice. Let's check. You can all see this. Nope, you can't see anything. Share this tab. Beautiful. Okie dokie. Let me get that one running. Right. So we already spoke about before about Encode Club, about our positioning as an educator, a developer ecosystem. You've heard all of this before. We talked about what this education series is, which is a 2-week program to prepare you, to onboard you to the Aptos MOVE ecosystems and prepare you for what comes for the hackathon that is running concurrently, which I think Blake will drop into chat. This is a hackathon run by our friends at Dora Hacks for you to build on the skills you learn in this short course and build cool DeFi projects within the Aptos ecosystem. We'll be talking specifically about DeFi next week as well as the Aptos ecosystem and the opportunities that come with it specifically. Those two workshops are on Tuesday and Wednesday, and then for those of you that are in London, we're doing a specific Aptos meetup on the 22nd. Again, the link can go into chat. If you want to join the hackathon directly, scan this QR code. It's not run by Encode, so you'll notice a slightly different experience. I'll stay on this slide for a moment, but we encourage you to take part and do that. Cool. So I'm Anthony, I'm the CEO of Encode. We last week talked about Aptos. So this workshop is more specifically about Move. I'm going to recap what we talked about last week in very brief terms. We talked about Aptos. We talked about being a product of its history, being associated with Facebook and DM, and the language being invented by Facebook. We had 3 teams that spawned out: Linera, Aptos, and Sui. Aptos is the one we're talking about today. The pitch of it was to be Web3 that runs like Web2, that we focus on performance and reliability. We do this through parallel execution. We will have a very robust consensus. We want to have this safe by design Move programming language we'll talk about today. And we want to have speed, safety, and composability to take on 2 major L1s, which are Solana and Ethereum. Hypothetically, this means a TPS of 160,000. In reality, real-time metrics do trail more mature ecosystems. And Move, which we'll talk about today, is this statistically typed, formally verified programming language that's inspired by Rust, that has this resource orientation, and treats digital assets as first-class citizens, which we call resources, and that we are going to enforce strict rules, mainly for security purposes, about how those resources are handled, such as that they can never be accidentally copied or implicitly discarded, and that assets behave as intended, which kind of creates some of the more replaces some of the more problematic elements, particularly of Solidity, Solana, and Rust. Does something very, very similar. We'll talk about some of this stuff specifically in the workshop, so we don't need to go back. And we'll talk about the prover as well. We talked about some nice statistics. This one's quite a nice one, but we'll come back to it a bit later. So let's move on to the topic of today's workshop, the Move language specifically. So, as discussed, we want to introduce you to the programming language of Aptos, which is Move. Move is one of the key reasons why you would pick to work within the Aptos ecosystem, or to pick a protocol like Aptos. It's going to be a very different experience to the JavaScript-like environment of Solidity, and not too far away from the Rust-based environment of Solana. It is a strongly typed, resource-orientated, fairly simple, I would hope, dev-friendly environment that has security baked in with formal verification, also for security. We're engineering it from the ground up to address some of the security challenges inherent in blockchain smart contract developments. The strongly typedness, the resource-oriented language is going to provide a simplicity and developer friendliness, which should make it, I think, quite a compelling choice for building secure applications, particularly DeFi applications. Security, you'll find, is not an external consideration, which will then require a lot of spend on audits, etc. The core design principles bake in security directly into the type system, which we'll see in some code examples later. The language includes built-in support for formal verification, which allows developers to create mathematical proofs of a contract's correctness and implements a comprehensive bytecode verification process before any code is deployed to the network. This is quite a proactive approach to security at the compiler level, which is going to help prevent common vulnerabilities and establishes Move as a robust platform for creating applications, which are going to have a lot of TVL and important things go into them. Okay, we're going to start with the concept of a resource. We talked about it a little bit earlier. This is sort of the most important concept when we think about the Move language. It's very similar to Rust. where the resource types are an explicit representation of digital assets, things like currencies, tokens, NFTs, fungible tokens, and we're going to have very strong ownership semantics. And the compiler is going to enforce that these assets cannot be copied or implicitly discarded. And this is a foundational security measure that ensures both the scarcity and integrity of digital assets. Unlike a simple data structure in a conventional language, you'll see this phrase, we treat a resource as a first-class citizen whose life cycle is strictly controlled by the type system. The language design is going to clearly guarantee rules for ownership, making it possible for us to accidentally duplicate or lose valuable on-chain assets, something that happens with Solidity quite a lot. You'll notice that with the move semantics, there's going to share quite a lot of similarity to C++, particularly with associations with standard move, and we're going to use this just like in C++. In the transferring ownership of a resource, like a memory pointer from a temporary object to a new owner, thereby hopefully avoiding a costly data copy. You'll also notice STD unique PTR, just like in C++, is providing a wrapper that enforces single ownership of a resource. And while Move's name and philosophy are inspired by C++ concepts, its implementation is fundamentally different. In C++, STD Move is a static cast that serves as a hint to the compiler, relying on the programmer to ensure the move from object is not used unsafely. By contrast, in Move, the semantics are a core unyielding property of its type system. Let's talk about the Move compiler. The compiler is going to enforce the linearity of resource types as a security feature, not just a performance one. In this sense, a Move resource is akin to a C++ standard unique PCR in that it cannot be copied, but this enforcement of this rule is a core unchangeable function of the language itself. This distinction is crucial for developers to grasp, and as it highlights how Move elevates a coding practice into a fundamental security guarantee, very much like Rust. In this sense. We also have the concept of modules versus scripts. In the Move language, things are architecturally divided into two primary program types, modules and scripts. This separation cleanly distinguishes between reusable on-chain state and ephemeral user-initiated actions. So modules here are akin to libraries or smart contracts in more traditional Solidity developments. They are responsible for defining struct types and the functions that operate on them. A module's primary purpose is to establish the schema for Move's global storage and to define the rules for updating that storage. Again, very smart contract-like. Once published, a module becomes a permanent fixture on blockchain, again, like a smart contract, stored under a specific account address and can be invoked by other modules or scripts. So modules here you should see just like smart contracts. Scripts serve as executable entry points similar to a main function in a conventional programming language. They are used for one-time transaction-specific operations and are not published to global storage. The sole purpose of a script is to call functions from already published modules to perform state changes. Scripts are designed with limited capabilities. For instance, they cannot declare new data types or directly access global storage. This architectural constraint is a security feature as it prevents arbitrary state chaining code from being deployed on the network. So very different to smart contracts in that sense. So structs are user-defined data structures in Move that can contain fields of various types. By default, by definition, a struct is a hot potato and is designated as linear and/or ephemeral. This means it cannot be copied, dropped, or implicitly discarded or stored in global storage. The ownership of a struct value must be explicitly transferred, and the value must be accounted for by the end of its function's execution. This default behavior, while initially counterintuitive for you as developers accustomed to garbage collection, is a powerful security primitive that is going to prevent data loss and ensure that all values are deliberately handled. The term resource, as mentioned earlier, is a specific classification for a struct that maintains its default properties of not being copyable or droppable. This makes resources ideal for representing unique digital assets like currency or tokens whose integrity and scarcity must be guaranteed by the system. We also have the concept of abilities, and to relax the sort of hot potato behavior of structs, we're going to introduce 4 annotations, 4 special type annotations, which we're going to call abilities. These abilities are going to grant specific behaviors to a struct, allowing its values to be used in different ways. These are copy, which is going to allow values of the struct to be duplicated. If a struct has copy, all of its fields must also have the copy ability. We can have drop. This is the ability. This annotation allows a value to be explicitly discarded or dropped at the end of the function's execution. This is the most common ability and is typically used for non-valuable data structures. If a struct has a drop, all of its fields must also have a drop. Store, this is the ability. This ability or annotation permits a value to be stored inside a struct. That's the key ability. This is crucial ability for defining the components of an on-chain resource. And key, this ability designates a struct as a top-level resource that can be stored directly in the user's account within the persistent global storage. A struct must possess the key ability to use with global storage operations like move to and move from. A key security rule is enforced by the compiler. If a struct has the key ability, all of fields must also have the store ability. This rule ensures that the entire data structure of an on-chain resource is well defined and verifiable before deployment. These abilities provide altogether a fine-grained control mechanism allowing developers to create highly specialized data structures for secure asset management. To go over those again, they are the copy, the drop, the store, and the key. Cool. We also have function visibility and entry points. Move functions are declared within the fun keyword. They support different levels of availability to control access from other parts of the blockchain. Internal functions are the default and can only be called from within the same module. Public functions can be called by any module or script. And the public friend functions are more restricted form of public access. They can be called from within the module or by modules explicitly declared as friends, but they cannot be called by scripts. This provides powerful, secure access control mechanisms baked into the language itself, allowing for controlled interactions between smart contracts. An entry function is a special type of public function that serves as a transaction entry point. These are the functions that a user would call directly from a wallet or command line tool to initiate a state change on the blockchain. The block entry function entry keyword is used to differentiate these public functions from others that are meant to be called by other modules. This is not theory, but it's some of the core information you should sort of know before we get into some specific code examples. To briefly recap, as mentioned, we have this strongly typed, resource-orientated, hopefully quite developer-friendly language that bakes security in. We've defined the concept of a resource where basically there are things like assets, currencies, NFTs, tokens. We've noted the similarities between Move and C++. There are a few differences. It does have a fundamentally different implementation, but if you know C++, you'll probably be having a good start. The compiler is going to force a lot of these security features on you, which is a good thing. Makes it a little bit safer as compared to Solidity. And we do have these concepts of modules and scripts, very similar to sort of typical smart contracts in Solidity development, where a module is very much akin to a library or a smart contract, and a script is an executable entry point, similar to a sort of main function in conventional programming languages. We also have the concept of structs, which are sort of these hot potatoes, and then within that, different sort of abilities, the 4 being copy, drop, store, and key. And then we talked briefly about function visibility and entry points. So you'll want to set up your Aptos Move environment. I hope after this you start playing around and start building things. Broadly, the Aptos command line interface is the primary tool for interacting with the Aptos blockchain. And the Aptos team has done a lot to sort of make this pretty low friction. You've got a few options. Mac OS, the easiest way to do it is to use the Brew package manager and installing by running brew install Aptos. Windows, I recommend using PowerShell, but you can also use sort of broad package managers like Scoop. If you are sort of cross-platform and use sort of Node.js, you can use npm install via npm install at Aptos Labs. /Aptos-CLI. All of this are on the public documentation. This should all be pretty straightforward. The second thing you'll want to do is initialize your project and account. The Aptos NIIT command is going to be crucial here for simplifying the onboarding process. And running this command will automate several key processes. It will configure the CLI for the dev network, which is basically a DevNet is a test environment that's going to refresh every week. It's going to create a test account for you with a unique private key and public key, i.e. generating a cryptographic account address. And it's automatically funds this new account with some testnet APT. We talked about APT last week and its function as for governance and validator incentives, but you are going to need it to fund module smart contract activities. And this process will also save the account information in a hidden config file, which this abstraction is quite useful because if you are new to blockchain, which I don't really suppose anyone here is, it can all look very complicated. We are going to recommend that you use the Move VS Code extension, which is actively maintained by the Aptos team. We've got some key features like semantic highlighting, real-time diagnostics, auto-completion, and seamless integration with the rest of the Move toolchain. And hopefully for writing, formatting, debugging, it will have the same sort of convenience you would expect from traditional programming languages. You're going to want to use the Move Prover, which is an integral part of the ecosystem designed to validate the correctness of Move code. And we talked about formal verification before. That's baked into the Move Prover to allowing you to mathematically prove that your smart contracts are behaving as intended. So I very much recommend you use those. And it should make getting started pretty easy and look like conventional software development. And you can also then integrate a lot of the AI tools you're almost certainly using. Okay, so let's look at your sort of building a smart contract. The most simple one is going to be building a sort of hello blockchain one. Step one, going to get a bit verbose now. You're going to use the Aptos CLI to create a new project. I recommend in your own time you do this step by step. That's why I've been a little bit more verbose on these slides to try and do this yourself. We are following a lot of the Aptos documentation here, but it's nice to have someone talk you through it as well. You're going to start by using the Aptos CLI to create a new project with the Aptos Move NIIT. And this is going to set up a directory and a move .tml file for project configuration. Two, you're going to write the code. We'll write a message that defines a message holder struct with a key ability. You'll have an entry function called setMessage that allows the user to store or update their message on chain. This example also includes a getMessageView function for retrieving the message and a unit test to verify the logic. Now I'm going to try to keep things to one slide. So I've put lots of nice code examples in these slides, which I suggest you use afterwards. But this is what the code you're going to run is going to end up looking like with our nice defined Hello Blockchain module at the top, some nice resource definition, and also the message itself down at the bottom here. I don't know if that's showing up. Yes, it is. Step three, you're going to want to compile this. So we're going to use the compiler command, which will convert our source codes into bytecode that the Aptos virtual machine can execute. This is the crucial part, as it's using the named addresses flag to map the module name to your account address. Four, we're going to test. Move has powerful built-in unit testing, and you can write tests directly into your .move files using the hash test attribute and run them with the Aptos Move test. This allows you to verify your contract's logic before deployment, which is crucial for security and looks a little bit like this. You're then going to deploy. The Aptos Move publish command will deploy your bytecode to the blockchain. The CLI will then also importantly show you the gas fee. Gas obviously defined as two things. Well, one thing really. Basically, the computational cost of your transaction, plus a little tip added in as well. Nothing to worry about in DevNet. When you do get to mainnet, becomes a very serious concern. After deployment, you'll get a transaction hash when we can verify everything on the Aptos Explorer. Looks something a little bit like this. Once your module compiles and all tests pass, we'll be ready to deploy it to a live network. You'll want to verify this on chain. You can then paste your account address into the search bar and see your deployed module listed under the modules tab. You can also view the transaction that funded your account and the transaction that published your contract. Once your module compiles and all the tests pass, you'll be ready to deploy it to on Aptos as discussed. To interact with your live contract, you can use the Aptos move run command, and you're going to specify a function ID and provide any necessary arguments, such as this. In terms of the prover, that offers a lot more beyond the basics. The move prover is a standout feature for formal verification. It uses mathematical reasoning to prove your code's correctness and help you build secure things. A little bit of code that you can run there. If you want a nice gas report, you can use this. You'll want to debug. The CLI is going to offer powerful flags, especially if we're using the move VSC extension. You can simulate a transaction locally with detailed debug information or get gas reports as discussed. When building a full stack app, things are going to get a little bit more tricky. I've put a little code example in here. You're going to want to interact with a front end as well. Here's a nice sort of TypeScript SDK example for a sponsored transaction using Alice and Bob. If you want a nice good example of a hello world, I've put it in here just to talk through it. This is sort of a little bit like the hello blockchain one, a sort of quintessential starting point when building with a move. It demonstrates how to create a module and define a function to hold a string, which is a resource owned by the account that published it. The message, just to kind of talk through some of the logic here, the module allows accounts, the message struct rather, is a data structure which is going to be used to hold the message content. We've got two fields here. The key, a string that acts as a unique identifier for the message, and a value, a string that stores the actual message text, and a few other bits beside. We've also got a nice fungible token example in here, which is going to allow us to create a new token standard. Fungible means tokens can be replaced for each other. Non-fungible means we've got some specific metadata that makes a token unique. Here we're defining a module for a fungible token called Aptos coin using a framework, using the frameworks discussed. And this is a digital asset that is interchangeable like a dollar. The INIT module function is the initialization point for this Aptos coin and runs once the module is published. The create fungible asset function creates the core token resource, and it defines the token's properties. The metadata is a description of the token, and it's here you can see it includes the name and our symbol and a brief description. The mint capability function is going to give the token owner the ability to create new tokens, and the freeze capability is going to allow the owner to freeze tokens, making them non-transferable. The burn capability will allow the owner to destroy tokens and create account. A new account is created to hold the APT resource. We also have an NFT module, which does much the same, except we're creating NFTs, i.e. non-fungible tokens, i.e. ones that have fairly unique metadata. You can run this code and get a nice one for yourselves. And last but not least, I've given you some nice code snippet for a function visibility and unit test. This is going to show you how to use different function visibility keywords and include a basic unit test to verify the functionality, a key feature of Mood. This code snippet is from a module called Access Control, which demonstrates different function visibility levels in smart contract environments like Aptos. It shows us how functions can be made accessible to different callers. We've got different functions like the function visibility, public entry, that could be called from anyone outside the module. We've got a function without a visibility modifier. We've got the public friend function. We've got the unit test function and much more beside. So there's a little bit of a whistle-stop tour of the Move programming language, guys. The best way to get stuck in, quite frankly, is by using some of these code examples and the broad Aptos documentation. If you're familiar with Rust, you'll have a very good time. If you're familiar with Solidity, a lot of the concepts will be not unfamiliar to you, but perhaps the way we do things security-wise, resource allocation-wise, module-wise, is going to be a little bit different. You're in a wonderful opportunity because with AI tools, you should have to, especially with the security features that Move bakes in, do as little coding as you've ever possibly done. And I recommend, particularly with the Move VSC extension, and perhaps with some coding agents, the latest Gemini model as an example, you start writing smart contracts with beautiful front ends with AI, and that plus all the things that Move bakes in should mean some very good smart contract work. We're going to look at this more specifically in the case of DeFi and the Aptos ecosystem next week, but we're just going to spend a moment looking at the upcoming hackathon, or the on-running hackathon. Let me hope that loads. 1 second. You'll see there are 100K of prizes, guys. Lots of hackers already taking part. Various bounties you could build on, and you have until about a month's time to build fantastic things. I recommend you, if you're not registered, you register now. You can build something around trading, payments, new financial prizes, and also get one of these massive prizes here. Also various office hours to help you as well. And there's actually an Aptos specific MCP, which is a sort of AI tooling to help you build Aptos smart contracts. So I recommend you use that. Okay, guys, thank you very much for joining this workshop. If you have any questions, you can DM me or Blake, or use the platform directly. It's been a pleasure to chat with you all, and I hope you have a very good evening, morning, afternoon, wherever you are. Thank you very much.